Hello, and thank you for viewing this video on what is a microcontroller. This presentation has been developed for new users of microcontrollers and will focus on some basic concepts. Subsequent videos will go into further detail on microchip's PIC microcontrollers and DSPIC digital signal controllers. In this presentation, we will discuss the following. A high-level overview of the fundamental components of a microcontroller, or MCU for short, will be discussed, including the central processing unit, or CPU, the system clock, memory, and finally peripherals. We will also identify some common everyday products that use microcontrollers. You'd be surprised at how often in your day-to-day activities you actually come in contact with these devices. So let's begin with the big question. What is a microcontroller? In the simplest of terms, a microcontroller is basically a computer that comes in a variety of packages and sizes. In fact, you could make many comparisons between a microcontroller and a personal computer as shown here. Now I should mention that a PC typically performs a number of tasks or runs a variety of programs simultaneously. So for example, you could listen to music while typing in a word processor or even have a web browser open all at the same time. A microcontroller, on the other hand, is typically dedicated to a single task. However, if we take a look at the basic components that make up both a PC and a microcontroller, we'll see many similarities. To start, every computer on the market will have a central processing unit, or CPU. This is the brains of the whole system that does all of the calculations and logic operations in the background, allowing your programs or software to function. A microcontroller similarly has a central processing unit that performs these same operations. A microcontroller also has memory, just as your PC has a hard drive or RAM. The memory allows the microcontroller to store information so that it can be used at a later time. Just like your PC, a microcontroller's memory is also used to store programs that are specific to that single task we spoke about earlier. An essential component to any computer system is its clock. This controls the speed at which your CPU thinks or processes information, prints things onto your screen, or downloads music or video from the internet. A microcontroller similarly has a system clock based off an oscillator. This oscillator can be thought of as the computer's engine. Without it, nothing would work. You could have a brand new car with all the latest bells and whistles, but without an engine, these are useless. When you order a microcontroller, this will be one of the essential features you will consider. The oscillator speed will determine how fast your microcontroller will run, which could impact certain aspects of your application, such as resolution, response, and even power consumption. Finally, in order for you to communicate with your PC, you need certain peripherals, such as a keyboard or mouse to input information, and a monitor to view the output of the system. A microcontroller is no different. In order to input information or receive information from the microcontroller, you will need peripherals. Peripherals on a microcontroller are usually associated with a particular pin on the package. So if you want to communicate a certain piece of information with the device, or receive a certain piece of information from the device, you will connect circuitry to that specified pin to accomplish this. These four basic components of the microcontroller, the processor, memory, system clock, and peripherals, are what differentiate one type of microcontroller from another. Maybe for one application you need a microcontroller that can operate extremely fast, or maybe you have a lot of information to store on the device requiring higher memory densities. Another factor, perhaps the application requires a certain type of peripheral. All of these options are why companies such as Microchip offer a wide variety of products. With all these different options available, microcontrollers are therefore able to function in a wide variety of applications. Anything from a simple remote control for your television to communication devices such as cell phones, medical applications like digital thermometers, utility meters, home appliances, automotive applications such as tire pressure sensors or key fobs to let you get into your car, solar panel interfaces for energy harvesting, and much, much more. All of these uses made available from a tiny computer that could be no bigger than the size of a cracked piece of pepper. Let's take a look at a simple application example to show the power of adding a microcontroller to your design. Shown here is an application that lights an LED when a push button is pressed. In order to light the LED 3 times successively, you would naturally need to press the push button 3 times. But what if we added a microcontroller to this simple design? Now we've added a pretty powerful component that adds intelligence to our system. You could then program the microcontroller to recognize when the push button is pressed, wait a period of time, and then flash the LED 3 times. This is a pretty basic application, but as you could probably imagine, the possibilities of even this simple circuit are limitless. Maybe you'd like to count how many times the push button was pressed, or create a real-time clock on the microcontroller and then be able to calculate what time of day the push button was pressed. So let's summarize what we've discussed. A microcontroller is a very small computer with similar components as a standard PC, only integrated onto a single chip and usually dedicated to a single task. Some of these fundamental components include a central processing unit that does all of the thinking, memory, a system clock derived from an oscillator that serves as the engine for the device, and peripherals that enable communications between the CPU and the outside world. For comments, suggestions, or additional information, please do not hesitate to contact Microchip's academic program at academic@microchip.com. Thank you.